A success story in space travel must eventually come to an end. A fundamental question arises. How long can Voyager 1 continue flying before it finally runs out of juice, or we lose contact with it? And then, of course, there is the world-famous 1990 image that shows our Earth as a tiny blue dot from a distance of 6 billion kilometers. But what would we actually see if we were to turn on Voyager's camera today? From today's perspective, it seems almost absurd, but when Voyager 1 set out into the vastness of space on September 5, 1977, no one suspected that this was the beginning of one of the greatest success stories in space travel. No wonder, after all, the originally predicted lifespan of the identical Voyager probes was just 5 years, and what are now the most remote outposts of humanity had actually only been launched to gather new insights into the outer planets of the solar system, which had been little explored until then. No sooner said than done, but after the probes had examined Jupiter, Saturn, Uranus, and Neptune, NASA decided to extend their mission and finally send them to the edge of our home world. And that's something we just have to keep in mind. As children of their time, the Voyager probes are simply built to the technical standards of the 1970s. This means nothing less than that their storage capacity is 1,000,000 times less than that of a modern smartphone. Furthermore, the transmission data of our current mobile phone connections is almost 40,000 times higher than that of the two ancient probes. However, this does not mean that Voyager 1 and 2 are chugging through space like dusty old machines. Quite the opposite. In reality, they are racing through space at a speed of around 61,000 kilometers per hour. By way of comparison, the so-called muzzle velocity of a pistol bullet is only 1,260 kilometers per hour. The fact that such breakneck speeds are necessary in the vast expanses of the universe is shown by the following. Although Voyager 1 was already on its way to the outer reaches of the solar system after passing Saturn in November 1980, it took until August 2012 before it reached the so-called heliopause. As already mentioned, this is the outermost zone of the heliosphere, and thus of that extended area in which the solar wind, together with its magnetic fields, is effective. Behind the heliopause lies the mysterious interstellar space, or space far from the stars, in which the solar wind's area of influence ends, lying dormant. How contact with Voyager 1 is maintained at the time we created this video for you. Voyager 1's journey had already lasted 17,280 days, and as mentioned at the beginning, it has since put a distance of 2,477 billion kilometers, or 16,561 astronomical units, between itself and the Sun. To refresh your memory, the length of an astronomical unit corresponds to the mean distance between the Sun and Earth, which is around 150 million kilometers. In the case of the distance that now lies between us and Voyager 1, however, we are dealing with 4 times the distance between the Sun and far-off Pluto. But how is this cosmic long-distance relationship actually maintained? Or, to put it another way, how do the experts manage to stay in contact with Voyager 1 at all? Well, first and foremost, a lot of patience. Because, to put it mildly, communicating with the probe is actually a laborious process. A signal sent from Earth takes around 23 hours to reach Voyager 1. Conversely, it takes almost another day before the Earth-based scientists receive the probe's response. Well, that is, if they actually receive a response at all. Of course, in fact, the communication has repeatedly caused headaches for NASA experts. The last time this happened was in October when Voyager 1 was supposed to turn on just one of its heaters, but instead mistakenly triggered a protective mechanism that deactivated the Zand radio transmitter. To restore contact, NASA eventually had to resort to the S-band transmitter, which had not been used since 1981. But fortunately, the engineering team was able to detect the weaker signal from this transmitter and continue to communicate with the probe. However, it's in the nature of things that you can't just ring Voyager 1 in the mysterious world of interstellar space with just any old smartphone. Instead, experts used the Deep Space Network, a global network of radio antennas that had to be repeatedly expanded for the Voyager mission. In fact, the Voyager program is one of the few projects that requires the continued operation of the colossal 70-meter antennas and the associated receiving technology. This, in turn, involves considerable costs, and yet the time for savings now seems to be in the distant future. As soon as the 70-meter antennas are no longer needed, they can be decommissioned, and experts estimate that this will be the case by the mid-2030s due to the steadily increasing distance by the Voyager probes. While Voyager 1 is already over 24 billion kilometers from the Sun, this distance is growing by a further 540 million kilometers, or 3.6 astronomical units, every year. But does the final radio blackout also mean the end of Voyager's journey venturing into the unknown? Well, not at all. Unless something unforeseen happens, the Voyager probes will still be bearing witness to our existence when the human era is likely to be long over. And we don't just mean the probes themselves, but also the special baggage they carry. This is called the Voyager Golden Record, and it consists of data plates with image and audio information about Earth and its inhabitants. So we are dealing here with nothing less than a message to extraterrestrials, whose estimated lifespan is 500 million years. Experts like Stephen Hawking, however, have emphasized that it may not be the smartest idea to reveal our existence and position so freely. After all, we cannot predict which alien civilization, possibly hostile, will ultimately get hold of this information. Be that as it may, Voyager 1 will probably not get up close and personal with aggressive aliens for another 300 years or so when it enters the Oort cloud, postulated in 1950 by Jan Hendrik Oort as the origin of long-period comets. It is a spheroidal collection of astronomical objects located up to 100,000 astronomical units, or 1.6 light-years, from the Sun. But since Voyager 1 has not yet covered even a single light day between itself and our mother star, it will take another 30,000 years to cross the Oort cloud completely. Another 10,000 years later, it will again fly past the star G445 at a distance of 1.6 light-years. Conveniently, the celestial body will literally be approaching its probe guest because, while G445 is currently still 17 light-years away from the Sun, it will then have approached it to within 3.45 light-years. And if Alan Cummings has his way, the Voyager journey will not be over for a long time yet. The C-Tech scientist, who has been involved in the planning and realization of the Voyager program since 1973, is convinced that the two twin probes could even fly another billion years. However, it's debatable, to put it mildly, whether the veteran probes will still be working smoothly from a technical point of view. NASA is already pursuing a strict power-saving plan, during which more and more instruments are being switched off in order to be able to continue supplying the spacecraft with the necessary energy. What if we turned on Voyager's camera today? In return, the Voyager probes have provided us with around 67,000 images of our solar system, literally giving us a new perspective on our home world. For example, we now know that Saturn is by no means the only planet in the solar system to have rings. The mission has also added numerous new moons to our star maps. And although the discovery of Jupiter's moon Io had already been recorded many centuries earlier, Voyager 1's images provided an unprecedented insight into the pockmarked face of this peculiar satellite. But Saturn's moons, Mimas, Dione, and Titan, and of course the large gas planets themselves, were also captured in an unrivaled level of detail at the time. And yet, the last photo greeting from Voyager 1, the aforementioned pale blue dot, was taken almost 35 years ago, taken at the suggestion of Carl Sagan and later voted one of the best photos in space science of all time. The impressive image once again shows us how small we are in the cosmic whole. At the same time, however, it also raises a fundamental question. What would we actually see if we turned on the Voyager 1 camera today? If the probe turned around once more and took a last photographic look at its earthly home, would it be able to recognize anything at all? After all, we must not forget one thing. On the pale blue dot taken from a distance of 6 billion kilometers, our Earth already appears as an infinitesimally small, not even 10% of a single pixel in size. Unfortunately, it's not that easy to reactivate the Voyager camera for a new look back. So, dedicated probe enthusiasts have to resort to simulations, and although these are not real photos, the results are still very impressive. The Sun, our mighty giver of warmth and life, is no more than a faint blurred point of light, and the planets that orbit our host star can only be guessed at best. And while the pale blue dot still represents the photo of the Earth taken from the greatest distance, the simulation transforms our entire cosmic neighborhood into a cluster of tiny dust grains in one fell swoop. But isn't it fascinating that those dust grains also carry our world, our reality, and all of our hopes and fears? The dimensions of the cosmos are truly difficult to grasp, and yet that is exactly what Voyager 1 would see if it were to turn its gaze back to its home planet. And now we would be happy if you would take a look at the subscription button, press the thumbs up, and subscribe now to never miss a new video from us again. We'll see you soon.